Welcome back to Aurora Tech Channel. Today I'll be reviewing the QiDi Q2. We've actually had this printer for almost 10 months, so this turned into an unexpected and unintentional long-term test. When QiDi first sent me the early version of this machine, the multi-filament box didn't work very well, so we had to wait through a few rounds of hardware and firmware updates. Especially after reviewing the Max 4 with the same box, we found that while it prints slower than other AMS-style systems, it now works reliably enough for normal use. So today I want to share my full experience with the Q2.
The standalone price of the Q2 is $499, and if you want the multi-filament box, you can add $150 to get the combo. This is a fully enclosed machine with a build volume of 270 by 270 by 256 millimeters, which is about 11% larger than Bambu Lab's standard size machines. The table space required for the standalone machine is about 16 inches by 20 inches, or 410 by 500 millimeters, and the height is about 20 inches, or 500 millimeters. When adding the QiDi box on top, you need to add about 12 inches, or 300 millimeters in height. If you want the box to fully open, you will need to add about 20 inches, or 500 millimeters of clearance. The build is pretty robust. The net weight of the printer itself is about 40 pounds, and with the QiDi box, the full combo is over 60 pounds. This makes it the heaviest machine I have tested in this size category. The motion system uses a linear rail on the X-axis and linear rods on the Y and Z axes. The maximum nozzle temperature is 370 degrees Celsius. The bed can reach up to 120 degrees, and the heated chamber can reach up to 65 degrees. Since the chamber has its own 280-watt PTC heater, it can heat up from room temperature to 60 degrees in just 12 minutes. The nozzle is a bimetal hardened steel nozzle, and the whole setup allows you to print engineering-grade filaments right out of the box. There is no automatically opening vent like on Bambu Lab machines. However, the top cover has a slide-back design, so you can push it back and leave a few inches of gap to keep the internal temperature cooler when printing PLA and TPU. When fully enclosed for printing ABS and engineering-grade materials, it has a 3-stage filter with HEPA and activated carbon before exhausting the air back into your room. For part cooling, besides the print head cooling fan, it also has a large auxiliary fan on the side. For other features, it has a 4.3-inch touchscreen, a 1080p camera, 32GB eMMC storage, and support 2.4 GHz Wi-Fi and Ethernet. This lets you print within your local network without using any third-party cloud service. You can also use a USB drive if you want to print completely offline. For software, besides its own QiDi slicer, it fully supports the regular Orca slicer. You can send prints and manage the printer directly in Orca slicer and access the full Fluid Web UI.
I'd like to thank QiDi for sending us this machine to review and for sponsoring today's video. As always, even though this is a sponsored review, we won't hold back when pointing out any issues or drawbacks I find during testing. This helps give potential buyers a realistic expectation and also provides useful feedback for the manufacturer to improve future firmware and software updates. With that said, let's get started.
My test unit came in 2 boxes, the Q2 and the multi-filament box. I will start with the printer first. On top, there is the glass top cover for the printer and a USB drive. I already put the glass top cover on. It can slide back a few inches like a vent to let cool air in when a lower printing temperature is required. The screen mounts at the front of the printer. Just connect the cable and snap it on. No screws are required. When using this as a standalone printer, we will snap on the spool holder. The spool itself hangs on the side with a short Bowden tube acting as a filament guide to the inlet. That's all we need to install, and we can now turn on the machine. Starting with language selection, it reminds you to remove all the protective materials as well as the screws used to secure the bed. Then it moves the bed up so you can remove the remaining foam at the bottom. After the print head protective materials are also removed, it starts a self-test. It starts with the heaters on the extruder and bed, followed by the heated chamber and all the fans. After that, it levels the bed and starts a 6x6 36-point probe. Followed by input shaper calibration. After Input Shaper is calibrated, the self-test is completed. I will first test it without the multi-filament box and start a preloaded benchy to make sure the printer is working. As you can see, this is a fast-tuned benchy with an estimated time of just 17 minutes. Most machines normally won't print at this high speed because they need to balance speed and print quality, but it is a good test for us since I am also going to measure the noise level. So I will let the benchy print a few layers, reach top speed, and then test the sound level. Interestingly, the sample G-code places the benchy on the right side of the bed next to the auxiliary fan to ensure strong cooling. When both the door and top cover are open, the sound level stays in the mid to high 50s. Once the door is closed, it drops a few decibels to the low to mid-50s. Since the top cover is still open to the maximum, I will try closing it to see how much of a difference it makes. It drops another 3 to 4 decibels to the low 50s. However, this fully enclosed environment is not suitable for PLA or TPU, as the internal temperature will get too high during long prints. The print finishes in 22 minutes, 5 minutes longer than the estimate. I think this print demonstrates that the printer can print that fast, but at this high speed, the result doesn't look very good. First, cooling is definitely an issue, and the surface is also not very smooth. The front lines look fine, better than the other overhanging areas. The top also has some under extrusion, or the line width in the slicer was set too wide, as you can clearly see gaps in some areas. I will then use the default slicer profile to print another benchy for comparison. QiDi has its own skinned version of Orca Slicer with some minor modifications. Inside the Device tab, you can access the Fluid Web UI to monitor and control the printer. Let's take a look at the default print profile. The maximum speed is set to 300 millimeters per second. Travel speed is 500 millimeters per second. The maximum acceleration is set to 10,000 millimeters per second squared. It is a typical Core XY speed, not the fastest, but in line with most new generation Core XY machines. Using the default profile, the estimated time is 44 minutes for the benchy. The print finishes in 46 minutes, 2 minutes longer than the estimated time. The print time is much slower than the fast sample benchy, but I don't think I have to tell you which is which. As you can see, the overhanging areas are much better, and the surface quality in this area is also improved. The front has no major difference, as both prints look good there. The top of the normal print also looks much better, there is no under extrusion, and the line spacing looks normal. For the rest of the tests, I will stick with the default slicer profiles for all different types of filament. I will do my benchmark prints, starting with the number slider. This print tests the clearance of the model. It finishes in 2 hours 41 minutes, which is about the average print time among all new generation machines. The top looks good with almost no stringing, and the text is clear. The bottom looks perfect, and there are gaps between the tiles. Even my brother can move all the tiles smoothly. Next is the tolerance test. This print tests whether objects can fit together properly. It finishes in 1 hour 21 minutes, slightly faster than the average of 1 hour 30 minutes. On the square side, it can almost clear the tightest 0.05 millimeters and stops at 0. On the cylinder side, it clears up to the tightest 0.05 millimeters and stops at 0, so it gets a perfect score on the cylinder side and an almost perfect score on the square side. This suggests that some minor pressure advanced tuning may be required. Then, I will print the Honeycomb box to test the retraction of the extruder. It has to extrude a tiny bit of filament, retract right away, and move to the next spot. It seems the extruder handles this print pretty well. It finishes in 2 hours 35 minutes, also slightly faster than the average of 2 hours 45 minutes. The honeycomb patterns were printed beautifully, with no stringing and no broken patterns. The result is pretty good, even when compared side by side with other good quality printers. Next, I will print the Robo Alpaka for the surface quality test. In this test, I will use Tricolor Silk PLA, which shows imperfections like ringing and ghosting more clearly than regular PLA. In the middle of the model, there is more room for acceleration, so the print head moves much faster, but it is still slower than those ultra-fast printers. This print finishes in 4 hours 43 minutes, not far from the average of 4 hours 45 minutes. The surface quality looks good. I would say it is better than average. Let's compare it with other printers. Compared with QiDi's new flagship, the Max 4 is a little faster, and the surface quality is also slightly better. Compared with the Bamboo Lab H2C, the H2C is about 16% faster, and the surface quality is also better. Compared with the X2D is about 18% faster, and the surface quality of the two machines is similar. Compared with the Snapmaker U1, the U1 is about 15% faster, and the surface quality of the U1 is also better. Compared with the Prusa Core 1, the Core 1 is a few minutes faster, but the Q2's surface quality is better. Finally, compared with the fastest Core XY I have tested, the QiDi Q2+. The K2+ is 31% faster, although the surface quality of the two machines is similar. I will then print a first layer sheet to test the bed leveling and Auto Z offset. It is mostly good, but not perfect, as I can see some uneven areas. When I tried to peel it off, the lines in the upper right corner separated. As you can see, these lines are not close enough to each other, but the rest of the sheet is fine. That means the bed leveling still needs some further tuning, but this kind of first layer should be good enough for almost any print. I will now try some different materials, starting with PETG. I will print a large trash can that maxes out the Z height of this printer. I am printing with 3 walls because the trash can is large and I want it to be thick and usable. This print finishes in 6 hours 8 minutes. The good thing about Core XY is that the surface quality at the top of the print does not look too different from the bottom. Unlike a bed slinger, when the print gets taller, you will usually see more ringing. The inside of the trash can is also pretty nice, with minimal stringing. The bottom is beautiful, and it's stuck very well to the bed. Next, I will test the heated chamber of this printer by printing some ABS. The chamber heats up quite fast. Going from a room temperature of 22 degrees to 60 degrees only took about 17 minutes. This print finishes in 3 hours 44 minutes. I think this is one of the best ABS prints I have printed with this same model. There is zero warping at the corners, the patterns are difficult to print well, and it just nailed them. There are some imperfections on these overhanging areas due to minimal cooling with ABS. The bottom also stuck pretty well, and I have no complaints with this print. Then, I will try to print some high-temperature PACF. Regular PACF is already strong, stiff, and heat-resistant, but this high-temp PACF has a heat deflection temperature of 195 degrees, which I definitely do not need for my use cases. However, I still want to test this material as well as the dryer. This spool was just stored in my camera cabinet and was not dried before printing, so I do not expect it to print well. As expected, the result is awful. I will not blame the printer, as undried nylon is expected to print like that. Since the QiDi box also has a dryer feature, I will use it to dry this filament. I've had this printer for about 10 months. The early version of the QiDi box did not work well, but after a few minor hardware updates, including an injection molded riser, a redesigned 4:1 splitter hub, and some minor components for the nozzle wiper and poop bin metal piece, it seems to be working pretty well now. We will do more multicolor and multi-filament prints later. For now, I just want to use the filament drying feature. Just like the AMS2 Pro, it requires you to unload all filament before you can start the dryer. I will set it to the maximum of 65 degrees, which is still not ideal for nylon, but let's dry it for 6 hours and see if we can get some improvements. It heats up to 65 degrees in about 22 minutes. After about an hour, the humidity drops to less than 10%, and my second thermistor inside also shows the same measurement, so I think the temperature reading is pretty accurate. After about 6 hours, the lowest humidity I can see is about 6%. I will then reprint the model and see if we get any improvements. There is a firmware glitch where you can just keep drying, load filament, and start printing. I think this is a very good glitch, and this is probably the only thing this filament box does better than the Bamboo Lab AMS2 Pro. After 6 hours of drying, I can see some improvements, but nylon generally requires 70 to 90 degrees. For high temperature nylon, it may require even higher temperatures. So, the maximum of 65 degrees from this dryer is not enough unless you dry it for an extended period of time. I will dry it for another 24 hours and restart the print. This time the print looks pretty nice. I did not see any stringing or oozing during the whole print. As expected, it finished beautifully. Let's compare all three of them side by side. The difference is night and day. Even though 65 degrees is not very effective for nylon, with 30 hours of drying, the result is still pretty good. I will then do one more engineering grade filament before I move on to multi-filament prints. PPSCF can technically print at around 300 degrees, but at the lower end of the temperature range, layer bonding can suffer, especially for functional parts. This is a moonclip unloader for my dad. Since this machine can reach up to 370 degrees, I will push the temperature to the maximum to improve layer bonding. This PPSCF was stored in the same camera cabinet as the PACF, but it seems it does not require extra drying. This print took 1 hour 43 minutes, and the result is pretty successful. The surface quality looks good, even without drying. Listen to the sound. It sounds like aluminum, and it is very stiff. If you watched my Max 4 review, you may already know that this QiDi box didn't perform too well in multicolor printing in terms of speed. But let's use the same QiDi box and do some basic tests with this Q2. I will start with this color benchmark print, a 4-color simple square that uses all 4 colors on every single layer. We have a total of 76 color changes in this small print, and the estimated print time is over 3 hours. Let's check how much time is required for each color change. The first one is from gold to blue. It took 2 minutes 41 seconds, over a minute longer than most other AMS-style single nozzle setups. I will put all the records in the top right corner. When changing from blue to gold, it took even longer, at a little over 3 minutes. From gold to skin color, it was a little faster at 2 minutes 31 seconds. From skin color to white, it took 2 minutes 40 seconds. From white back to skin color, it took 2 minutes 24 seconds, which was the fastest so far, since white usually won't contaminate other colors, so it requires less purging. Finally, from skin color back to gold, it took 2 minutes 30 seconds. Generally, most new-gen AMS-style single-nozzle setups take a little over 1 minute to 2 minutes per color change. Let's take a look at where this setup spends more time. As you can see, when the box retracts the filament, it starts at a very slow speed. It spends almost 18 seconds just retracting a short distance, and then it starts to speed up. But when the filament reaches the 4:1 splitter at the back, it slows down again. Then during loading, the filament does the same thing. It slows down at the 4:1 splitter, loads at a normal speed for a while, and then slows down again before reaching the print head. So, not including purging, just loading and unloading the filament takes 1 minute and 12 seconds. Some efficient setups, like the Bamboo Lab AMS Pro, already finish the whole process and start printing in that amount of time. This is the major reason why this machine is much slower for multicolor prints with extensive color changes. The print finally finished in 3 hours 52 minutes, 46 minutes longer than the estimate. The filament usage was not far off. The model and the prime tower were both accurate, and the purge waste was a few grams less than estimated. Compared to other single-nozzle AMS-style setups, the filament usage is similar. None of them has an obvious advantage. However, the print time of the QiDi box is below average. It is 35% slower than the Bamboo Lab A1 and 42% slower than the Creality Spark X i7. And I don't even need to mention how it compares to the dual-nozzle X2D or a tool changer, since they work more effectively than any single-nozzle AMS setup. I will also do one more regular multicolor print, the Vegeta model. This print requires 247 filament changes. The estimated print time is 11.5 hours, but since there are so many filament changes, we can expect the actual print time to be even further off from the estimate. But let's see. It seems that when printing multiple colors, as the nozzle travels back and forth between the prime tower and the model, it creates more stringing than usual. This print finished in 13.5 hours, about 2 hours longer than the slicer estimate. The filament waste was not bad, actually better than average. Let's compare it with other single-nozzle AMS-style setups. In terms of filament waste, it performs better than the FlashForge 85X and the Creality Q2 Pro, and it is similar to the Centauri Carbon 2. But for print time, it is the slowest among all the single-nozzle AMS-style setups I have tested. To confirm whether my filament caused the stringing, I tried printing a Benchy with unnecessary support to see if it would string without the prime tower. As you can see, it didn't string like the Vegeta model with the same filament. Since I printed the first one with QiDi Studio, I will try using Orca Slicer to slice the same model again with the default slicer settings and see if there is any difference. This time, with the file sliced by Orca Slicer, I don't see the same stringing from the prime tower to the model. The one sliced with Orca Slicer took 1 hour 16 minutes longer, and it also didn't show the filament usage on the screen. I think the time difference was mainly caused by the extra support generated by Orca Slicer, as well as the larger prime tower. However, with the same machine, the same model, and the same filaments, the one sliced by Orca Slicer definitely printed better. Even though I would probably stick with Orca Slicer, QiDi should still take a closer look at the wipe settings in their slicer to reduce stringing during multi-filament printing. I will now print some models using one material for the model and a different material for the support. I will print a speed loader for my dad with PETG and use PLA as the support interface. That way, we can minimize the number of filament changes. As you can see, it only has 41 filament changes, so it will probably only slow down the print by an hour or less. This print went pretty smoothly, but it still took 26 minutes longer than the estimate. The filament waste is manageable, with only 22 grams of purge waste from 41 filament changes. With PLA as the interface, the supports are super easy to remove, and you can see the overhanging parts are very clean. This is a very nice print, and I have no complaints aside from the extra time caused by the multi-filament box. I will make one more multi-filament print before wrapping up the pros and cons of this machine. This time, I will print a chain with PACF and use ABS as support. If I only use ABS as the support interface, this print takes just 1 hour 31 minutes because there are only 7 filament changes, so it won't really slow down the print at all. But unlike PETG with PLA, which still sticks a little but is very easy to separate, PACF and ABS don't stick together at all. So using ABS only as the interface is very likely to fail. Because of that, I changed it to print both the support and the interface with ABS. This increases the filament changes from 7 to 55 and adds over 2 hours of printing time, but that is the only way to make this model work, and I have printed this model many times before. One of the ABS tree supports failed, but I don't think it mattered much since it still provided some support to the PACF. The print finally finished in 4 hours 12 minutes, about 30 minutes longer than the estimate. The purge waste was 28 grams for 55 filament changes. The chain actually printed very well. I could just take it out of the support, and the overhanging areas were also very clean. Okay, let's talk about the pros and cons of this printer, starting with the pros. 1. The build is robust, with the machine itself weighing 40 pounds and the full combo package exceeding 60 pounds. This is the heaviest machine among all regular-sized machines I have tested. The hardware specs are also strong, featuring a linear rail on the x-axis and a 280-watt chamber heater that can reach 60 degrees Celsius in about 12 minutes. The print volume is also about 11% larger than Bamboo Labs standard-size machines. 2. The 370 degrees high temperature nozzle, along with a 120 degrees bed and a 65 degrees chamber, makes this an excellent setup for printing ABS-based filaments. I also printed PPS-CF at the maximum temperature of 370 degrees and achieved significantly better results compared to other machines with a maximum nozzle temperature of 300 degrees. 3. The print quality is decent. The surface quality is better than average, the tolerance is almost perfect right out of the box, and the extruder also handles excessive retraction pretty well. 4. It fully supports Orca Slicer. In the Device tab, you can access the full Fluid Web UI, which provides additional controls for advanced users. Nowadays, many companies like to reskin Orca Slicer and make their own version. Of course, QiDi also has one of those things, but as long as it fully supports the official Orca Slicer, that doesn't hurt. This is a big advantage for anyone who has many different printers and wants to manage them with a single slicer. QiDi is also one of the sponsors of Orca Slicer, and I really appreciate what they have done to help make this project sustainable. 5. The multi-filament box is undeniably much slower than other AMS-style setups, but in terms of reliability, after a few minor hardware updates, it works on par with other AMS variants. The one thing it does better than the Bamboo Lab AMS is the heater. The firmware has a glitch that allows you to start a print while dryer mode is still on. For moisture-sensitive filaments like high-temp PACF, this is actually the way I prefer to print. Of course, if you do that when printing PLA, it could become a problem because the filament may soften and jam the gears. But it is still a very useful glitch, and hopefully, QiDi will not fix it. Instead, they should turn it into a feature. They just need to warn users to be careful and make sure they know what they are doing instead of completely blocking drying during printing. In terms of the standalone machine, the Q2 performs pretty well. However, the multi-filament box operates more slowly than any other option on the market, so my cons will mainly focus on the QiDi box. I will also give some suggestions to QiDi and to anyone considering this machine. Now let's move on to the cons. After timing the color changes, I found that the system requires an additional 60 to 70 seconds per change compared to other AMS-style systems. That means for a print with 50 color changes, you can expect it to take about 1 hour longer than most other machines. This isn't a major issue for simple models like a 4-color Benchy with minimal color changes. However, for more complex prints with close to 1,000 color changes, this could add almost 20 extra hours, making the difference much more significant. The real cause of the slowdown is the 4:1 splitter. It is mounted externally at the back of the machine instead of being integrated into the box like the Bamboo Lab AMS. This not only slows down the filament loading process, since the filament needs to feed much more slowly through the splitter when it is farther away from the pushing force, but it also makes the Bowden tube much longer than it needs to be compared to an internal splitter design. This longer filament path also results in weaker pushing force when the filament enters the extruder, so they have to slow it down to maintain reliability. I don't think many people would use this setup to print 16 colors, but if you did, it's hard to imagine how messy it would get with 16 Bowden tubes and multiple splitter hubs hanging off the back of the machine. QiDi said they will release a 7:1 splitter for connecting multiple filament boxes, but I still don't think this kind of setup is practical.
In conclusion, the Q2 works pretty well as a standalone printer with robust hardware, a strong heated chamber, and a high-temperature nozzle. If you're printing ABS or different kinds of engineering-grade filaments, it's a good option. However, the multi-filament box undeniably performs below average in terms of speed. But it also costs less than average. It just costs $150 extra when you order with the combo. I don't think it's that bad as it still packs with a few useful features. For comparison, a 4-spool filament dryer like the SUNLU S4 already costs over $100, and a dual spool feeder that supports filament backup mode like the Infinity Flow S1 Plus costs around $180. The QiDi box can work as a dryer that can reach up to 65 degrees, and the temperature is pretty accurate. With the nice firmware glitch that allows you to dry while printing, plus 4-spool backup mode, it becomes even more useful. As long as you set all the filament types and colors to the same, it will automatically switch to the next spool once one spool runs out. Considering the price and the features, it still offers pretty good value. It still performs okay in some cases. For example, when printing simple models like a sign with different colors for the background and text, or when printing the model with one filament and using a second filament as the support interface, those prints won't trigger as many filament changes as a complex multicolor PLA print. This can minimize the disadvantage of the filament box. However, if you mainly want a printer for multicolor PLA prints, this is probably not the one you should pick. But if you are an advanced user who mainly prints with engineering-grade filaments and wants a Mini-Max 4 at a much lower price, this is actually a pretty good option. QiDi also has the Q2C, which has slightly lower specs and does not include the heated chamber, but it is priced $100 cheaper. But personally, I like the Q2 more. If you're interested in the Q2, I'll put the links to both the Q2 and Q2C in the video description. Don't forget to check out AuroraTechChannel.com, which monitors prices for popular 3D printers, laser engravers, and CNC machines to help you find the best deals. That's it for this video. If you found it helpful, please give it a like and subscribe to our channel. Thank you for watching, and I'll see you next time.